recording the session and open this. So, what are you studying?
This is intermediate algebra. It's similar, and it's basically the same thing that I was doing when I was in high school working with you.
Is it called Acuplacer by chance?
No, it just like on the course that I signed up for, it's just intermediate algebra for science and business majors.
Okay.
So
that's what you're majoring in? Is do you have a specific major?
Business administration.
Okay. And you're living in a dorm or?
It's like a dorm, yeah. I actually live closer to the university. I'm in the same town as the university.
How big is your school? How many people are on that campus?
Oh gosh, I don't think I can tell you. There's a ton of people.
It's like CU, kind of?
Yeah, it's pretty big.
Yeah, it seems like Santa Barbara is.
Yeah.
It's like, I wouldn't be surprised if you're looking at 25 to 50,000 people.
Yeah. Okay. It's hard to find parking.
I'll bet. Are you working or just going to school?
Just going to school.
Uh-huh. Okay. All right. I got your 3 documents here. Let's open is this the first one here?
Yeah, I kind of just jotted down some problems from my homework that, like, I didn't really understand that well, or I got, like, a weird answer.
Okay.
So, yeah.
Okay. You want to go through these first 8? I'll let you direct. I presume we probably are going to want to go through every problem of every sheet that you sent me.
Yeah, if that's okay with you.
Oh, yeah, it's fine. I never know how much material you have to go through and how long you have to go through it. So, do you know when you're taking, or when are you taking this exam? Do you know?
Well, we have a quiz every class period.
Uh-huh.
So that's why I chose, let's see, Tuesdays and Thursdays, because this time is right before my class, because my math class is at 5:30.
Okay.
So I get like a refresher right before class.
Uh-huh.
And to just go over stuff and make sure I do well.
Okay.
But, yeah.
Yeah, this is, you're right. This is very similar to Algebra 3, college algebra, or Algebra 3, whatever you want to call it. Let's look at that numerator. The key on these things is always to work from the inside out.
Right.
Okay. So let's look at that inside.
Okay.
Okay. And actually, let's look at that inside, starting with that. So what is minus 5 minus a minus 7?
That'd be positive 2.
Okay. So I can essentially erase that with positive 2. And now let's eliminate the absolute value signs. What's the absolute value of positive 2?
2.
This negative sign stays there.
Right.
Because it's outside of the absolute value sign.
Right.
Okay, now this part here, a minus 2, what does that become?
Positive 2?
That becomes positive 2. So now we have minus 2 plus 2.
Okay, and that's 0. Because I know the whole answer is 0. I just, like, was doing something really weird. Okay. It was really frustrating me, so I thought I'd add.
This is an interesting problem because we've figured out that the numerator is 0. Do we need to even look at the denominator?
No, because the whole
Right.
thing would
No
be...
matter what the denominator is, the answer is going to be 0. So,
Okay.
I mean, if they make you show all of your work, maybe you would want to figure out what is the denominator, just for clarification. What's this going to be?
5.
Okay, so we really have 0 divided by 5. But
Still
0 divided by any number is going to be 0.
right.
So once you see a numerator of 0, you really don't need to go much further. There is a problem if you have 0 divided by 0. That's called indeterminate. We don't know what that is. That might be 0, it might be infinity, it might be some number. I'm presuming you're not going to get any problems like that because that's calculus.
Right.
So we won't even worry about that. Once you see a numerator of 0, you know the answer.
Right. Cool. That's what I was doing wrong. I was doing something weird with my adding and subtracting on that
Well,
one.
you know, that's what it comes down to. It really does. I've stressed to you for 3 years that the basic, if you really want to be strong at math, you got to be strong at adding and subtracting and multiplying.
That is for sure.
And, you know, as long as you have a calculator around that you can use perfectly, you probably can get by. But what really works a lot better is if you can memorize single-digit stuff. In
Right.
other words, you don't want to really have to use a calculator to do these things. And I don't think you did. You knew that minus 5 plus 7 was equal to 2. And
Right.
it's those little kind of calculations that, you know, if you had a calculator in front of you and you were trying to get that, you're just as likely to make an error as you are doing it in your head. Merely because you have 3 minus signs. So doing this,
oh, go ahead, sorry.
doing that on a calculator would not be trivial. I mean, I'm guessing that 80 or 80% of people would get that correct, but probably 20% would get it incorrect on a calculator.
Yeah.
So calculator isn't always a good solution.
I try not to use it that much. My math class last semester, it was a non-calculator class.
Oh, cool. Cool.
Yeah.
I like that.
So,
I like that. That really, that must have been difficult because you really must have had to practice your calculation ability.
yeah, it was tough for me and everything else. The big move out here was I was just homesick and distracted, so I didn't do too well.
Well,
So.
first semester in college is always tough.
Right.
But you'll get through it.
Yeah.
So, we're taking, that means cube root.
Right.
And we're taking the cube root of something that is being cubed. What do you think the answer is?
That's where I get stuck.
Okay. Well, let's do it a different way. Let's do it a way where you'll never get stuck. Let's write it in exponential format.
Okay.
In other words, here's the inside. And the cube root is the same as taking it to the 1/3 power.
Okay.
Okay? Now, the question is, how do you do that?
You would...
What is 2 cubed to the 4th power equal to?
That would be, let's see, 6, is it 16?
What do you do with the exponents? No, work this way first. Don't do the 2 cubed first.
Okay.
In other words, that's the same as 2 to the 12th.
Oh, okay.
Because when I'm doing a double exponentiation, I'm multiplying the exponents.
Okay.
Okay? So what is this one?
That would be negative 15 to the 1/9.
Which is negative 15.
Okay.
Okay? And if you look back at it, the cube root of something being cubed always is whatever the something is. In other words, I could say the cube root of x cubed is always x, no matter whether x is minus 15 or 10 or
Oh, okay.
a million.
So like, kind of another way to think about it is that like the cube roots kind of like cancel out each other.
Cube root cancels cube. Same thing as, excuse me, let me open this again. Same thing as square root. In other words, the square root of 10 squared is 10. Why?
Okay.
Because 10 squared, the square root means to the 1/2. Multiply those exponents and you get 10 to the 1.
Okay, yeah, okay, that's making sense now.
Tell me what all these things at the bottom mean.
Those are just things, I know these are going to be on the quiz. I
But
I jotted them
they don't have
down.
anything to do with these problems?
No, they don't. The ones that I put like a little star asterisk by is like if you could just explain it a little bit more to me.
Okay.
You could like make up a problem or something like that.
Okay. So I'm a little puzzled by number 3.
Uh-huh.
Because it's 3 root 5.
Right.
Which does not simplify.
Right.
So I'm not sure what they want you to do there. I doubt seriously that they want a decimal approximation, just because you're beyond that at this point. You know, it looks like you're leaving everything in radical notation, especially when I look down here at what they call radicand. It's not like they gave me 3 root 20.
Okay, so I found the problem in the book. I forgot to take a picture of that. It actually does want it in the decimal notation.
Okay. Do you have your calculator?
Yes, I do.
What, you have the TI-84 or the Inspire?
The TI-84.
Okay. Tell me what 3 root 5 is.
Oh. That's all I have to do. I'm so used to not using a calculator.
That's the only thing I can think of to do, because you cannot simplify it.
Right. Okay.
What is that?
Well, if you were to round it up, it'd be
like 6 point something.
7.1, yeah.
6.71?
Yeah.
And they may say they want it to 2 decimal places or to the hundredths place, or
yeah.
They might have said they wanted it to the thousandths place.
Yeah.
So whatever they ask for, just all it is reading off your calculator. Now, if it was a different problem, if they'd have said, what is this? I would have known instantly that they just want you to simplify that. Okay, that's the same as 3 root 4 times root 5, right? Because 20 is 4 times 5.
Okay.
Okay, and then root 4 is 2. So this becomes 3 times 2 times root 5, which is 6 root 5. So had they given you this as the problem, I would have instantly said 6 root 5 is what they want as an answer.
Okay.
But when they give it to you like this, there's no simplifying that. So I wasn't sure what they wanted. And if they wanted a decimal, that's fine. You can plug that into your calculator. Typically in math, that is the final answer.
Okay.
Any decimal you give me, 6.71, is an approximation. It's not an exact answer. The most exact answer you can have is 3 root 5.
Okay.
Okay? Four cube root 10. Well, this probably also is a calculus problem.
Like, okay, sorry. Never mind.
All right.
Talking.
In other words, I was looking at this and seeing if we could simplify it. And in order to simplify stuff, you need to be able to factor this number where one of the factors is a perfect cube number.
Uh-huh.
And I can't do it. And the only factors of 10 are 5 and 2. Neither of which is a perfect cube number. So I cannot simplify this. The only thing I can do is put it into a calculator and come up with a decimal. Now, do you know how to take cube root of 10 on your calculator?
I don't necessarily know how to do that.
10 to the 1/3. That's what cube root means.
Okay. That
now
makes sense.
You have to put this in parentheses also.
Okay.
You could also do 10 to the 0.333, but notice that's not going to give you an exact answer because I've rounded that off. I've dropped all the other 3's that follow behind that. So this is the better way to do it.
Okay.
This is the most exact way to do it. So the key is that when you're taking cube roots, that's the same as to the 1/3 power. Square roots are the same as raising it to the 1/2 power. Fifth roots are the same as raising it to the 1/5 power.
Okay, that makes sense.
If I'm raising something to the 2/3 power, what I'm doing is taking the cube root of it and squaring it.
Okay.
So this is what fractional exponents mean.
Okay.
And I could also write this as x squared to the 1/3 power, which gives me x to the 2/3 power. In other words, all 3 of those are the same.
Okay. Makes sense.
All right. Number 5.
But,
number 5 is a little different because we can simplify it.
Yeah. Can we go back to 4 just for like 1 second?
Certainly.
Because it says 4, and then like there's like a 4 in front of the cube root of 10.
Uh-huh.
And I looked in the back of the book for like the answer earlier.
Okay.
And how do I get, because when I typed 10...
You get the cube, start by doing the cube root of 10.
Uh-huh.
That's the way you do the cube root of 10.
Do I multiply that answer by 4?
Hold on, get that first. What do you get?
2.15.
Now multiply that by 4.
Oh, okay. That's what I thought. Okay.
That's your answer.
Okay, perfect.
Okay. Now, those were calculator problem, whereas these others are not. In other words, you have calculator problems where you end up with a radical that can't be simplified. Notice down here in your rules on radicals, this is what we're using. In other words, the square root of A times B is the square root of A times the square root of B.
Okay.
These are the things we use. The square root of A divided by B is the square root of A divided by the square root of B.
Okay.
So if I said to you, what is the square root of 9 over 4? What would it be?
3/2.
Yeah, because it's the square root of 9 over the square root of 4, which is 3 over 2.
Okay.
Okay? And whenever we're simplifying stuff, like this example here, square root of 18, the way we simplify that is to factor it. That's the square root of 9 times the square root of 2, based on this rule. Well, square root of 9 is 3, so that's how we simplify it. And this is the answer they're going to want. I don't think they're going to want you to turn this into a decimal.
Okay.
Okay? It's problems like this I almost never see, because I don't even know what they want as the answer. That's the simplified answer. That's the perfect answer. To turn it into a decimal almost requires instructions that say, give an approximate decimal value for this, rounded to the nearest thousandth place.
Okay.
Okay? Whereas problems like number 5 are not that at all. Problem number 5, they want you to just simplify it. So what's the first step?
You take the square root of 50 and 81.
Well, that's the first step. Separate it. Okay? Now, square root of 50 is what? You want factors of 50, one of which is a perfect square number. What perfect square number goes into 50?
5.
25.
25, right, okay.
That's what you meant.
Yeah.
And what's the square root of 81?
It'd be 9.
So my answer is 5, which is that, square root of 2 over 9, and I can write that in a variety of ways. I can write it as 5/9 square root of 2, or I can write it like that. The only thing I don't want to do is put it in decimal.
Okay.
Unless you've looked in the back of your book and all these answers are in decimal, which I can't, that's almost impossible. Because otherwise they wouldn't give it to you like this. If they wanted you to merely put that into your calculator, they wouldn't give you this problem. This problem is designed to let you simplify this into the most perfect answer you can give, which is 5 root 2 divided by 9.
Okay.
Number 6, cube root of 48 over 125. What's the first step?
You take the square root of 48. Well, you separate it. You take the
cube root
of
48 over cube root of 125. Okay. What's the cube root of 125?
Isn't that 5?
Uh-huh. So I'm going to replace that with 5. Okay. Now the cube root of 48. So we have to factor that. In other words, we want the cube root of one thing times the cube root of another thing. What are our perfect cube numbers? 1, what's 2 cubed?
4.
2 cubed.
Oh, 2 cubed is 8.
3 cubed?
27.
Those are the only 3 we have to consider. Because clearly 27 does not divide into 48. Nothing greater than 27 is going to divide into 48. But what does divide into 48?
8.
So I can make this the cube root of 8 times the cube root of what?
Times the cube root of, let's see, 6.
And now I can turn that into a whole number, an integer.
Okay.
So the answer is 2 cube root of 6. So when you're doing cube roots, you want to kind of memorize this list of perfect cubes. 4 cubes is 64. 5 cubes is 125. These 5 numbers will generally solve most of the problems you're going to get.
Okay.
But when you're trying to reduce a cube root problem, you want to do it by factoring the number into 2 factors, one of which is a perfect cube. Well, I found 8 is one of the factors of 48. That's a perfect cube, so I can do it that way.
Okay.
Number 7. First of all, we can just carry that along for the ride.
Okay.
In other words, this problem is really this. Once we figure out the answer to that, we'll be fine.
Okay.
Now, first of all, let's talk about the difference between square roots and cube roots. What is the square root of 4?
The cube root?
No, what's the square root?
Square root. 2.
What's the square root of negative 4?
2. No, negative 2.
Negative 2 times negative 2 is positive 4.
So.
It's imaginary. Remember imaginary numbers?
Oh, yeah, okay.
All right. Imaginary numbers come up with square roots, but with cube roots, they don't. In other words, if I take the cube root of 8, what do I get?
You get 2.
But if I take the cube root of minus 8, I get minus 2.
Okay.
Because minus 2 times minus 2 times minus 2 is minus 8.
Okay.
That's the only thing you have to do to make sure you've done it right, is multiply it back together again 3 times and make sure you get whatever is under that radical sign. Okay? So, let's go back and look at this problem. So, first of all, we know our answer is negative.
Mm-hmm.
When you take the cube root of a negative number, it's a negative answer.
Right.
Always. Okay? So, we have to figure out how to factor this thing where one of the factors is a perfect cube. Wow, let's list the perfect cubes again. 1, 8, 27, 64, 125.
Mm-hmm.
Do any of those numbers divide into that? 27.
27, okay.
I knew that did not. And this one you don't even consider. In other words, we're not really interested in 1 cubed. But this is 3 cubed, 4 cubed, 5 cubed. I can see that does not divide into it, which means nothing bigger than that's going to divide into it. 27 looks like it might. What is What is 162 divided by 27?
That is 6.
Now, I can put my negative sign wherever I want. I can put it there. It's got to go in one of them. I can also put it here, but in other words, what I know is that that is the cube root of negative 27 times the cube root of 6.
Right.
What's the cube root of negative 27?
The root of negative 27 is 3.
Minus 3.
Minus 3.
Cube root of 6, which I clearly cannot reduce any further.
Okay.
Now that happens to be the same answer as this. Because when I split it apart, I could have split it apart into a positive 27 and a negative 6.
Right.
Well, that would have given me positive 3 times the cube root of minus 6 had I split it this way.
Okay.
If I had a preference, my preference would be this answer over this, although I don't know that there's really any difference. A calculator is going to give you the same number. I'm not even sure there is a mathematical preference as to whether you should put the negative sign in front or inside the radical.
Okay.
Okay, this is another problem. We want to work from the inside out. Let me write it, and I'll say exactly what I mean by that. Now, whenever you have exponentials, they only apply to what is directly below them or what is in parentheses. Okay? So we're going to work for the inside out, and we're going to use PEMDAS. Remember PEMDAS?
Yeah.
Which means we're going to do parentheses first and then exponentials. But sometimes it's better to do the exponentials first and then the parentheses.
Right.
This is one of those times.
Okay.
Which calculation should we do first?
I would do 2 minus 3 squared.
Which of those do you do first? In other words, okay, so you're saying we should do that.
Oh, you have to multiply it by 3.
You have to square the 3 first.
Oh, okay.
In other words, do the exponential before getting rid of the parentheses.
Okay.
Well, what is this equal to? Right here.
Oh, well, yeah, negative 7.
Good. Because you do this part first.
Okay.
And this 2 does not apply to that negative sign. It's not in parentheses.
Right.
So this 2 only applies to what's below it, which is a 3. So this becomes 2 minus 9, and that's equal to negative 7. So let's erase everything we see. And I'm going to write in a negative 7 there. Now I can't quite get rid of the parentheses yet because it's being multiplied by this 3.
Right.
What's the next thing to do?
Multiply 3 by negative 7.
Let's finish doing our exponentials.
Okay, the exponential, so then you would...
Either one is actually works, but let's do this one over here. What am I going to be able to replace that with?
9.
Okay. And in this case, the minus sign is inside the parentheses, which means we're squaring minus 3. There's a huge difference between this and this.
Right.
In this case, we're squaring the 3, so we get minus 9. In this case, we're squaring the minus 3, so we get positive 9.
Right.
So we're going to replace that with positive 9. Now, still want to work from the inside out. We still want to basically follow PEMDAS. There's no more exponentials, but I see a parentheses, and I see a bracket. So our goal is to get rid of this parentheses, and then to get rid of this bracket.
Okay.
How do I get rid of the first inside parenthesis?
Multiply 3 by -7, and that's -21.
Okay, so I'm going to replace that with minus 21. And now how do I get rid of the bracket?
You add -21 to 9, and that's -12.
And I'm going to leave the bracket there for a moment. Now what do I want to do next?
Would you get rid of the brackets? Would you multiply 3 by -12?
Notice that what we have here is really A times B times C. In other words,
Okay.
the brackets are no different than this period here, or this multiplication sign here.
Okay.
What I have is 5 times 3 times minus 12. Same exact expression. Which means I can multiply them in any order I want. I can do the 3 times the -12 first. I can do the 5 times the -12 first. I can do them in order. That times that is 15 times -12 minus 180.
Okay. Okay, that makes sense.
So the biggest thing is to work from the inside out. Usually, instead of PEMDAS, I find myself actually doing EP first. I end up doing exponentials before I remove parentheses frequently. In fact, I can't think of any that were, well, if I had something like 4 minus 1 squared, I would do what's inside the parentheses first. So that would turn into 3 squared. So I would get rid of the parentheses. But if I had 4 minus 2 squared, all times 3, I'm not going to get rid of the parentheses first. I'm going to get rid of the exponents first.
Right.
Okay. So it kind of depends on the context you find the problems in.
Okay.
If I go over on time, remind me. This happens to be a strange day for me.
No worries.
I have a lot of back-to-back sessions, so I will have to leave close to 3. Let me look at the stars. Set builder notations.
Yeah, that's one I really want to focus on, and interval notation as well.
Okay.
Those are the two that I really want to focus on.
Let's start from the bottom.
Okay.
I know what you just said, but I'm going to need some help there.
Okay.
Not sure exactly what they mean by set builder notation. I understand interval notation perfectly. Compound inequality, I know what they're talking about. Everything else, I know what they're talking about.
Okay.
Let's make sure you understand this bottom one. A over P to any exponent. Remember what we did when we took this? Well, that's the same as 9/4 to the 1/2 power, which is always down there. It's 9 to the 1/2 power divided by 4 to the 1/2 power. That's all this thing says.
Right.
And I could make that 1/3 or 1/4 or 1/5. It would not matter.
Right.
Well, This is same thing, only multiplication instead of division.
Right.
This is the same thing as this, only they're starting with something, the square root. What they're saying is that the square root of 2 times 3 is the same as the square root of 2 times the square root of 3.
Okay.
Which means square root of 6 does not simplify. Because there are, I can't take a whole number out of it.
Mm-hmm.
Right? If I can only do that, is all I've done is turn it into 2 terms instead of 1. Well, 1 term's better than 2, so I never do that simplification. That's my final answer always. Same thing with square root of 10. That's square root of 5 times square root of 2, but neither of those were perfect square numbers, so I don't do it. That's my answer. Square root of 8, different story. That's square root of 4 times square root of 2. Well, I can pull a whole number out of that. So that's always the way I'm going to write square root of 8. Never going to write it as square root of 8. Always going to simplify it. So these bottom 3, I think you understand.
Yeah.
Okay. Let's talk about interval notation.
Interval notation? It's like...
I know what you mean.
Yeah.
Let's say let's say I had an inequality.
Wait, sorry about that. What did you say?
Let's say I had an inequality where my answer can be less than or equal to -1 or greater than 2. Okay. So how would I write that in interval notation? Well, I always start from the left. Since that's an arrow, it means it goes to negative infinity.
Right.
And I'm going to go up to this value, -1. And I'm going to use a bracket because that's a closed circle. I have none of this area in there. That's not part of my answer. But part of my answer is this area over here, so I have to use the in union with. And now I'm going to put a parentheses for the 2.
Right.
Positive infinity.
Okay, that makes sense.
So interval notation, the key things to remember is start with negative infinity if it applies, and go to positive infinity on the far right if it applies. Now, if I had an answer that went from -1 to -2, and that's the only answer, well, then my answer would be -2, -1. And assuming there were circles at both points, that's my entire answer. But they call it interval notation because most of the time you have multiple intervals as your answer. Okay? So interval notation allows you to combine intervals. Now, where does this come from? Well, if we look at the thing previous, compound inequality. If I told you that absolute value of x minus 5 is greater than 10, the way I solve that is I take whatever's inside the absolute value, which is, in this case, x minus 5. I make it greater than 10. But there's an or also. And the or is whatever's inside the absolute value, never change that. But now it's less than -10. In other words, that's how you do these absolute value compound inequalities. Okay, now let's solve this. Solve each one. We get x greater than 15 or x less than minus 5. Well, I could give this as an answer, which would be correct. But they said give the answer in interval notation. What would I do?
In interval notation? So you would,
What's the far left?
the far left is, you could do the parentheses and you do 15.
No, if we're going to work left to right, then I want to start over here, right? Because my answer is x is less than minus 5, which means it can go from negative infinity to minus 5.
Okay.
That's that interval right there.
Okay.
Negative infinity to minus 5.
Okay.
Or, what's the rest of it?
It would be 15 to positive infinity.
15 comma positive infinity.
Right.
Now the infinities always go with the parentheses, but brackets go with greater than or equal to. So if I were to change that to greater than or equal to 10, then that becomes that becomes that becomes that. And then all of a sudden, instead of going to minus 5 with a parentheses, I go with a bracket because it can be equal to minus 5. And instead of going with a parentheses on the 15, I go with a bracket because it can be equal to 15.
Okay, that makes sense.
It doesn't have to be greater than 15. In the first case, it did have to be greater than 15. But the moment I added that thing there, that's what makes the difference between when you use a parentheses or when you use a bracket.
Okay, and then just a side question. So, like, let's say I were to put that, like, on a little graph thing, if I were to, like, do the graph notation, what is for, like, I always get this confused, for, like, a closed circle that's, like, shaded in, is that for,
let's
like...
graph this one right here.
Okay.
Okay, my key numbers are obviously minus 5 and 15.
Okay.
Okay, and what I'm saying is my x values can be anywhere to the left of that.
Okay.
If that's a bracket, do I need an open or a closed circle here?
I feel like it's a closed circle.
Closed circle means it can be equal to minus 5.
Okay, so...
Same thing over here, because it's a bracket, and then my line goes to the right with an arrow meaning. So this picture is the same as that interval notation.
Okay.
Now, if I go back to the interval notation and I change it from brackets to parentheses, the only thing that does is turns those into open circles.
Okay. That makes sense. Okay. I always get that part confused, but now I get it.
And that's pretty much compound inequality and interval notation. Now, the other compound inequality they could give you would be something like x plus 7 is greater than 10 but less than 20. Okay?
Mm-hmm.
Well, how do I solve this?
Let's see here. So, oh geez, why am I stuck now? I just did this.
Well, this is a tough one. I mean, it's different. But basically, it's like a regular inequality. I can do anything I want as long as I do it to all three parts. So if I want to solve for x, then I want to get rid of that plus 7, right?
Right.
So I want to subtract 7. Well, if I subtract it from the middle, I got to subtract it from the right, and I got to subtract it from the left.
Okay.
What that gives me is 3 is less than x, which is less than 13. So if I were to graph that, I would go from 3 to 13 with open circles.
Okay.
If I were to put it in interval notation, what would it be?
In interval notation, they'd be closed circles.
No. In other words, describe this graph in interval notation. Let's not look at anything else but that graph. Interval notation starts with either parentheses or bracket.
Oh, so you would put parentheses around them?
What's the first number in our interval that's allowable?
It'd be 3, 13.
And that's close. There's no other interval to combine with it, so I don't use this use thing.
Okay.
In other words, that's the entire answer. That's the entire interval notation.
Perfect. Okay.
And that's a compound inequality also.
Yeah.
Even though it's not absolute value, it produces the same kind of compound inequality in that you end up with a range of values for x.
Yeah.
Which takes us to the set builder notations.
Yeah, I'm looking at my notes right now, and it actually makes sense. I don't know why I wrote that down, because what you just explained, like trying to find x, you put it's like a little squiggly kind of arrow thing. You know what I'm talking about?
This is what they mean.
Yeah, and then a line, or yeah, cool.
Like,
yeah.
Something like that?
Yeah, and then
that's set builder notation?
Yeah. Okay, I get how to do that now that I looked at it.
Give me an example of what they wrote.
One is like x, and then there's like a line dividing it, or a colon, yeah.
Colon, okay.
And then -8 less or greater than, or no, less than or equal to x less than 5.
Okay. That set builder notation basically is the same thing as just writing that.
Right, okay.
Okay? Now, give me the interval notation.
Interval notation?
Yeah.
That would be...
For this set. In other words, what this is saying is that we have a set of x where x is greater than or equal to -8, but less than 5.
Right, so it'd be...
Go ahead.
It would be a bracket, -8, comma, 5, and then parentheses.
Perfect.
Okay.
That is the interval notation of that set notation.
Okay, that makes...
The only difference is this part here.
Right. That's the part that was why I put it on there. I was like, wait, how do you get that? But no, it makes complete sense. Now you explained it way better than my teacher did.
Okay.
Yeah, so...
Let's see. You want to go ahead and schedule next Tuesday and Thursday?
Yeah, that'd be awesome.
Okay, at 2 o'clock. I got you down both. How far do you want me to take this out?
Let's see.
I can take it out as far as you want.
I mean...
That's not a tough time for me. That's usually a time that I'm open. So it's not going to hurt anything. It's not like if you locked up from 4 to 5, which is a busy time for me. But 2 to 3 is not. As you know, nobody gets out of school here till 3 o'clock, so I usually don't have anything at 2. So just kind of leave it open. We can just leave it like this.
Yeah, I mean, I would love to like keep this time maybe for like the whole semester, and if like you or I need to cancel, like I'm flexible.
Me too.
And
Me too. It won't hurt me at all if you cancel one of these. It's not like you're going to cost me another appointment. So we'll just
okay, because
leave it like this the whole semester. And if you ever need to cancel, try to give me as much notice as you can. But
yeah, most definitely.
anything works. Um,
Yeah.
am I sending the envoys to your dad or?
Yes, you will be sending it to him.
Okay. I think I still have his email address. I'm sure I do. So I will go ahead.
I can also text it to you if you would like.
I will do that. And actually, my prices are cheaper this year than they probably were last time I worked with him. They're
Oh.
32 an hour instead of 36.
Oh, okay.
So, and also, if you ever need to, you can do half-hour sessions.
Okay.
I do half-hour sessions online, which are 16 an hour,
Perfect.
half hour. So it gives you a lot more flexibility. But
All right.
Taryn, good luck. I will. The next time is all I will do is text the meeting ID number to you, just like I used to. I won't call you. I'll just text it to you right before 2 o'clock my time.
Awesome.
All right.
Thank you so much. You helped me out a lot.
You're welcome. Have a good weekend. Talk to you Tuesday.
You too. Bye-bye.
Bye-bye.